Have you ever pondered why time seems to fly when you're enjoying yourself, yet drags when you're bored? This is not merely a philosophical curiosity, but a question that taps into the very essence of our universe. Time, as we perceive it, is a relative concept. It's not an absolute entity that ticks away uniformly for everyone, everywhere. Just consider this. You're engrossed in your favorite book, completely lost in the gripping narrative. Before you know it, hours have passed, yet it feels like only minutes. Contrast this to a painfully dull meeting where every second feels like an eternity. This variance in our perception of time, although subjective, hints at a deeper, more profound reality. Our understanding of time, as relative and flexible, paves the way for a fascinating concept from the realm of science fiction, yet deeply rooted in scientific reality: time dilation. Perhaps the answer lies not in our minds, but in the fabric of the universe itself. In the realm of science fiction, we often witness the bending of time. But could it be more than just fiction? Let's delve into the enigmatic concept of time dilation and unravel its mysteries. Imagine you're on a spaceship, hurtling through the cosmos at near light speed. Back on Earth, your best friend is leading a normal life. Now here's the catch. If you were to return to Earth, you might find your best friend considerably older than you. Sounds like a plot from a sci-fi movie, right? Welcome to the world of time dilation. Time dilation is a difference in the elapsed time as measured by two observers due to a relative velocity between them or to a difference in gravitational potential between their locations. In simpler terms, it's the idea that time moves slower for a moving object compared to an object at rest. Intriguing, isn't it? But how did we come to understand this concept? We owe our understanding to one man: Albert Einstein. His special theory of relativity, proposed in the early 20th century, introduced us to the concept of time dilation. He posited that the laws of physics are the same for all non-accelerating observers, and that the speed of light in a vacuum is the same no matter the speed at which an observer travels. This led to the realization that time can appear to dilate or stretch, depending on the relative speeds of the observers. Now, before you start worrying about aging faster than your jet-setting friends, it's important to note that time dilation is incredibly minute unless you're moving at speeds close to the speed of light. So, your friend zipping around the world in an airplane is not going to age noticeably slower than you. However, in the grand cosmic scale, where objects can travel at incredible speeds, time dilation becomes significant. It's a concept that challenges our understanding of time, pushing us to rethink the way we perceive the universe and our place in it. So time dilation is not just a product of imaginative sci-fi writers, but a scientific reality. But you may ask, if time dilation is real, why don't we experience it in our daily lives? Well, the reason is simple yet profound. Time dilation, a cornerstone of Einstein's special relativity theory, is not typically observable in our daily lives because we move at relatively slow speeds. It's only when objects move at velocities close to the speed of light that time dilation becomes significantly perceptible. You see, our everyday speeds are like a snail's pace compared to the speed of light, which clocks in at a mind-boggling 186,000 miles per second. So as we go about our mundane activities, like driving to work or running to catch a bus, our speeds are just too slow to create any noticeable time dilation. But let's not be so quick to dismiss the impacts of time dilation in our day-to-day life. While we might not perceive it, time dilation does subtly influence our world. A case in point is the Global Positioning System, or GPS, as it's more commonly known. GPS satellites orbit the Earth at high speeds and also experience less gravity than we do on the surface. Both these factors lead to time dilation effects. The onboard clocks on these satellites tick slightly faster than clocks on Earth, by about 38 microseconds per day. If not corrected, this tiny difference would lead to GPS errors of about 7 miles per day. That's a lot when you're trying to find your way to the nearest coffee shop. So even though we may not be zipping around at light speed, time dilation is still at work, silently and subtly ensuring that your journey to that coffee shop doesn't end up taking you to a different city altogether. We may not feel it, we may not see it, but like a ghost in the machine, time dilation is always there, lurking in the background, a silent player in the grand theater of space-time. So, while we may not perceive it, time dilation subtly influences our world. The implications of time dilation are profound and far-reaching. Imagine, if you will, embarking on a journey across the cosmos, traveling at speeds close to the speed of light. Time on your spacecraft would pass slower relative to time on Earth. This means that you could potentially cover vast interstellar distances within what would seem like a relatively short time for you. However, upon your return to Earth, you would find everything drastically changed as Earth's time would have progressed much further. This concept, fascinating yet eerie, is known as the twin paradox. Let's take it a step further. Suppose we develop technology that allows us to travel near or at the speed of light. In that case, we might experience time dilation to such an extent that it could be perceived as time travel into the future. One might leave Earth for a short trip, only to return to a world hundreds or thousands of years in the future. But it's not just about space travel. Time dilation also affects our understanding of age. If two twins were separated, with one traveling at high speeds in space and the other remaining on Earth, they would age differently. The space-traveling twin would age slower than their Earth-bound sibling. So time dilation isn't just about bending the fabric of time, it's about understanding how we, as a species, could potentially interact with time itself. Time dilation opens up a universe of possibilities, quite literally. Time dilation, a concept both baffling and fascinating, challenges our understanding of reality. We've journeyed through its enigmatic nature, explored why it eludes our day-to-day perception, and pondered its profound implications. It's a concept that warps our grasp on time, bending it beyond the linear progression we're accustomed to. Yet, it's an integral part of the cosmic puzzle we're yet to fully comprehend. As we continue to unravel the mysteries of the universe, who knows what other time-bending truths we may uncover?